Hi, class. Unfortunately, I had to be out today, so I decided to make a video to help you guys with the material. I'm going to start with practice 6-2 because that was an area a lot of people had questions on. So I'm just going to work through a few problems in that area on that page. So we can first look at number 3. I think these are the ones y'all probably got pretty good, where we know that the diagonals are bisected on a parallelogram, so we can say that 2x minus 4 is equal to 10. If we add 4 to both sides, we get 2x equal 14. Divide both sides by 2, x is equal to 7. Okay, so that's our first problem, working through number 3. Let me do another example for you. Let's look at number 5. And in number 5, it says that AC, this line here, is equal to 24. Well, if AC is equal to 24, and once again, a parallelogram, these are bisected, so we know that x has to equal 24 divided by 2, or half of this whole segment. So x is 12. Okay, I'm suspecting this part may have given you a little bit more trouble. One of the things we said here was that if we have a series of parallel lines, like we have in the picture to the right, and we have two transversals, so here's one transversal, didn't mean to draw that curved, and here's the second transversal. If these sides are congruent, so are these sides, or these segments, I should say. So, for example, if these were all 2 in length, we know they're all congruent. If this one was 2.5, we would know that all of these were 2.5 also, because parallel lines cut through by a transversal that creates congruent segments on one transversal creates congruent segments on the other transversal. So let's apply it to the problem. When we look at the problem, it asks us to focus on this parallelogram right here. So really we're trying to find the sides of that parallelogram. So when I start out, it tells me that AE is 17 and that BF is 18. Okay, right away I see that each of these segments are congruent on this transversal. So this means all the segments on this transversal cut by those same parallel lines have to be congruent also. So these are all 17. Okay, and that means that these segments on this transversal must also be congruent. So each of these are 18. So now we've got all the information we would need to figure out the length of the sides. Because if NX is 17 plus 17, so that makes NX 34. And in this case, if this is 34, this side has to also be 34. So I can say BL is equal to 34. Now I can come to this side, and this is made up of segments that are all 18 in length. And 18 times 3 is 54. So I know that these two segments are 54. Okay, so hopefully that helped with that problem. Let's look at the bottom. Go down so we can see a little bit better. If we look at these bottom problems, we talked about how opposite angles of a parallelogram are congruent. So in this case, 2 would be 140. We talked about how consecutive angles have to add to 180. So if this is 140, this must be 40 degrees, and this must be 40 degrees. Okay? We also talked about looking at this angle, okay, where we have the diagonals here. We should be able, these are a little bit hard to read, we should be able to figure out what 1, 2, and 3 are here. Because if we've got, let's see, if we've got a transversal coming here, right? That's what we can think about. And we've got parallel lines, okay? We know that this has to be 50 degrees here. And we know this must be, these are what kind of angles, if y'all remember, 75-degree angles. Okay? So, and we know these two are equal. So 75 plus 70 times 75 is going to be 150. Okay, so these two angles have to split into what? They have to form 180 degrees, right? They're supplementary. So 75 or 180 minus 75 is going to give us 105. Okay? And opposite this would be 105 also, which would make sense. The full circle has to add to 360. So if we say 105 plus 105, that's 210. Let's see. Okay, if y'all checked on your calculators also, we should have gotten 360 going all the way around, assuming the vertical angles. Then here we know this triangle has to add to 180, so we got 75 plus 150, that's 125. If we take that away from 180, we know this angle is 55 degrees. Okay? And if this angle is 55 degrees, alternate interior angles across parallel lines, this is also going to be 55 degrees. So in the end, we end up with angle 1 equaling 55 degrees. We end up with angle 2 equaling 105 degrees. And we end up with angle 3 equaling 55 degrees. Okay, so that should give you an idea. I think I worked some on the bottom for you earlier. So that should give you an idea on 6.2 and help answer some questions there.